Hi everyone, it's Mrs. Summer here to talk about lesson 107, Valence Electrons. In this lesson, students will be able to explain the valence shell is the outermost shell and explain that valence electrons are the bonding electrons. So valence shell. So shell, when we say the word shell, we're talking about energy level. It's the outermost shell, also called the highest energy level, where electrons are in the atom. So previously we've talked about the quantum mechanic model and then also the Bohr model. So we can identify the valence electrons from either model. Valence electrons are electrons in the outermost energy level, or the shell of the outermost shell of an atom. The valence electrons are the electrons that interact with other atoms' electrons to form bonds. They're the whole reason we all exist. So the number of valence electrons is closely related to how reactive an element is. For example, sodium. Sodium has one valence electron. It is so incredibly reactive that even a small amount can create this large explosion. Neon, on the other hand, it has 8 valence electrons. It's not reactive or it's inert. And they use it in signs, and because one, it causes really pretty colors, but also because it's not reactive. It's not going to react with anything else if the sign breaks or anything like that. If we're identifying valence electrons from the Bohr model, all we need to do is look at the outermost ring. So in beryllium has 2 in its outer ring, so 2 valence electrons. And we can represent valence electrons by writing Ve minus. Helium, 2, it has 2 valence electrons as well. Lithium has 1 valence electron. And if we're all looking all the way over at platinum, if we look at this outermost shell, we see 1, and that is it. So platinum has 1 valence electron as well. So if we're identifying valence electrons from electron configuration, this is a little bit more challenging because we got to look at its energy level, or the number. And then we need to add up those exponents. So in this example, we have the third energy level, and we have 2 plus 1, so it's 3 valence electrons. In this example, there is only 1 s, so there are 2 valence electrons. In this example, there's 2 and 2, so we need to add 2 and 3, so 2 plus 3 equals 5 valence electrons. And in this example, we're looking at, let me use my highlighter. We have 3 and 3, and then we have 2 and 2, so 2 plus 2 equals 4 valence electrons. So you're always going to have to look, because remember, if we get higher up, and this was 1s2, 2s2, 2p6, 3s2, 3p6, let's say 4s2, 3d7. Well, this is where you have to look at 3, 3, and 3, but those aren't the outermost shell. What's the outermost shell here? It's actually this 4. So we're looking at that one and not, I gotta rewrite that. Then it was 3s2, 3p6, 3d. So it's actually this 4, because 4 is the highest energy level. So it's 2 valence electrons here. Does that make sense? Hopefully it does. But make sure you're looking at the highest number on electron configuration and then adding those numbers together.